everyone, in today's video we shall know about the alcohol, phenols and ethers. So general form of alcohol will be ROH and general formula of alcohol will be CnH2n plus 1 OH. So first we shall look into the preparation of alcohol. First method is from alkyl halide. When an alkyl halide reacting with an aqueous KOH gives an alcohol, and alkyl halide reacting with an AgOH, silver hydroxide, in the moist condition gives an alcohol. So next, from an aldehyde on reduction gives an primary alcohol, ketones on reduction gives an secondary alcohol, carboxylic acid on reduction gives an primary alcohol, ester on reduction gives an mixture of alcohol. Okay, so another important to remember is aldehyde and carboxylic acid both on reduction gives an primary alcohol. So next method is by Grignard reagent, where formaldehyde reacting with an Grignard reagent on hydrolysis gives an primary alcohol. Aldehyde reacting with an Grignard reagent on hydrolysis gives an secondary alcohol. Remember, only formaldehyde reacting with an Grignard reagent on hydrolysis gives primary alcohol. Remaining all the aldehydes gives an secondary alcohol. Next, ketone on Grignard reagent on hydrolysis gives an tertiary alcohol. And another important point, methanol CH3OH cannot be prepared by Grignard reagent. So next, ester reacting with an Grignard reagent gives an secondary alcohol. So by Grignard reagent method, aldehyde and ester gives an secondary alcohol. So next we shall know about hydroboration oxidation method. Hydroboration oxidation method. So in this method, where diboron is reacted with an alkene, the presence of a dry ether gives an alcohol, and this reaction will takes place by anti-Markovnikov rule. Anti-Markovnikov's rule. So hydroboration reaction takes place by an anti-Markovnikov rule, where addition of water molecule will be to an alkene. So next, another important reaction is oxymercuration demercuration reaction. So this reaction takes place according to the Markovnikov rule. Markovnikov rule. This oxymercuration or demercuration reaction takes place by a Markovnikov rule, where the addition of water will be to an alkene. So this is the important reaction, oxymercuration, where the mercury will be eliminated from the reaction. Okay, this is an important reaction where alkene is treated with an mercuric acetate in the presence of an THF. THF is nothing but an tetrahydrofuran. It's a tetrahydrofuran. You can prepare alcohol by this method also. So next we shall look into the properties of alcohol, where boiling point are higher due to the intermolecular hydrogen bonding in the alcohols. The reaction in which, very important property, listen carefully, the reaction in which OH bond cleaves, where the bond between the O and the H breaks, then it follows the order like primary will be greater than secondary greater than the tertiary. If the reaction in which CO bond cleaves, so reaction in which CO bond cleaves, then it follows an order like tertiary will be greater than the secondary greater than the primary. And also weak acids, so hence they follow an order like primary will be greater than the secondary greater than the tertiary alcohol, which means primary alcohol will be more acidic when compared to a secondary and tertiary alcohol. So next we shall look into the reactions of alcohol with other metals and other functional groups. So when an alcohol is reacted with an Na metal, gives an sodium alkoxide. Alcohol reacting with an acetyl group, this is an acetyl group, in presence of an pyridine gives an ester. Next, alcohol reacting with an RMGX, Grignard reagent. So when an alcohol is reacting with a Grignard reagent, it gives an alkane. It gives an alkane, RH. Next, alcohol reacting with an carboxylic acid in the presence of an S2SO4 gives an esters. So next reaction is important. It is also known as a dehydrogenation reaction will takes place when an alcohol is reacting with the copper metal. So what happens when primary alcohol is reacted with an copper or heated with the copper metal gives an aldehyde. Secondary alcohol heating with an copper gives an ketone. A tertiary alcohol heated with an copper gives an alkene. So next reaction is also important, the reaction with an concentrated H2SO4, where alcohol react with an concentrated H2SO4 at three different conditions. So at first conditions, what happened when an alcohol is treated with an H2SO4 at 383 Kelvin. At 383 Kelvin gives an alkyl sulfate. Gives an alkyl sulfate. So next, when an alcohol is reacted with an H2SO4 at 413 Kelvin, at 413 Kelvin, it gives an dialkyl ether. It gives an dialkyl ether. Alcohol reacting with an concentrated H2SO4 at 443 Kelvin gives an alkene. Gives an alkene. So this is an important reaction when alcohol is treated with an H2SO4 at different temperature. So at 383 Kelvin it gives an alkyl sulfate, at 413 Kelvin gives an dialkyl ether, at 443 Kelvin gives an alkene. So next we shall look into the distinguishing of primary, secondary and tertiary alcohol. You will be familiar with the Lucas test, where Lucas test is nothing but an concentrated HCl and anhydrous zinc chloride. So mixture of anhydrous zinc chloride and the concentrated HCl is known as a Lucas reagent. So when an alcohol is treated with a Lucas reagent, we can distinguish the alcohols by this test. So when a tertiary alcohol is reacted with an or treated with the Lucas reagent, it gives an turbidity immediately at room temperature. So at room temperature, tertiary alcohol will forms turbidity immediately, whereas secondary alcohol will forms an turbidity after 5 to 10 minutes. After 5 to 10 minutes at room temperature, secondary alcohol forms an turbidity, where primary alcohol does not give any turbidity at room temperature. Where primary alcohol does not form any turbidity at room temperature, but on heating the primary alcohol will give an turbidity. On heating it gives an turbidity. Forms an turbidity. So next, another important test while distinguishing the alcohol will be known as a Victor-Mayer test. Known as a Victor-Mayer test. Where what happens in the Victor-Mayer test is like primary alcohol, when it is reacted with a Victor or performed for the Victor-Mayer test, gives a red color. Secondary alcohol will form some blue color. Tertiary alcohol does not give any color at all. So tertiary alcohol does not give any color. Like the reaction for this Victor-Mayer test will be alcohol is heated or treated with an iodine in the presence of an, or along with the AgNO2 and HNO2 in the presence of an alkali solution like NaOH. This is the Victor-Mayer test, where alcohol will be treated with an iodine along with the AgNO2 and an HNO2 in the presence of an alkali solution like NaOH. This is known as a Victor-Mayer test, and primary alcohol if performed for this Victor-Mayer test gives a red color. Secondary alcohol gives a blue color, where tertiary alcohol does not give any color at all. Next we shall look into the phenols. First we shall know about the preparation of phenols. First method is by diazonium salt. First method is from diazonium chloride, when diazonium chloride on hydrolysis or reacting with water gives an phenol. Next with an Grignard reagent, when Grignard reagent is reacted with an oxygen along with the water gives an phenol. Next sodium phenoxide, sorry, not sodium phenate, it's an sodium benzene sulfonic acid. When sodium benzene sulfonic acid is treated with an NaOH along with HCl gives an phenol. Next will be the cumene. Cumene on oxidation along with the presence of an hydrogen peroxide gives an phenol. Next, benzene on oxidation. This is another reaction which is very important. Benzene on oxidation with a catalyst at 315 degrees Celsius. At 315 degrees Celsius, you get an phenol. So next, another important preparation will be known as a DOS process, where chlorobenzene is reacted with an NaOH at 573 Kelvin. When chlorobenzene is treated with an NaOH at 573 Kelvin, it gives an sodium phenoxide. Further, the formed sodium phenoxide is reacted with an HCl, gives an phenol. So next, another important preparations in the phenol will be known as a Rastix process, in which benzene is first treated with an HCl along with the oxygen in the presence of an copper or iron. In the presence of copper or iron, it will be formed as a chlorobenzene. Next, further, the formed chlorobenzene is steamed at high temperature at 425 degrees Celsius, gives an phenol. So what happens in the Rastix process? First, the benzene will be treated to the HCl along with the oxygen in the presence of a copper or iron. First, the benzene will be converted to an chlorobenzene, and next, that formed chlorobenzene will be steamed at high temperature, forms an phenol. So next, we shall look into the properties, where melting point of phenol will be 42 degrees Celsius and boiling point will be 183 degrees Celsius. Phenols are colorless and they are crystalline solid. They become pink on exposure to air due to oxidation. The color of the phenol will be changed to a pink when they are exposed to the air due to oxidation, and hence they are stored in the dark brown color bottles. So next, they are weak acids, where the blue litmus paper will turn into a red color when phenol is dipped. Next, phenols are stronger than alcohols but weaker than the carboxylic acid. In the phenol, electron withdrawing groups is present, that it increases the acidity of the phenol, whereas electron donating group decreases the acidity of the phenol. Next, we shall look into the chemical properties or some of the reactions of the phenol. So phenol reacting with an alkyl iodide. Phenol reacting with an alkyl iodide gives an anisole. Next, phenol on reacting with an benzene along with an acetyl groups in the presence of an NaOH gives an phenyl benzoate, and this reaction is also called as Scott-Beumann reaction. This reaction is also called as Scott-Beumann reaction. Next, phenol on reacting with an zinc gives an benzene, or from the benzene reacting with an zinc dust. It's also a preparation method of an phenol. So next, phenol reacting with an NaOH gives an sodium phenate, and that formed sodium phenate reacting with an carbon dioxide in the presence of an HCl gives an salicylic acid, which is also known as a Kolb's reaction. So next, phenol reacting or on oxidation with an chromate trioxide. On oxidation with chromate trioxide gives an benzoquinone, which will be in the pink color. Next, phenol reacting with an oxidizing agent like A2S2O8 forms a quinol and catechol. Gives an quinol and catechol. This is important reaction. Please remember it. Phenol on oxidation with an oxidizing agent like K2S2O8 forms a quinol and a catechol, and this reaction is also called as Elb's persulfate reaction. So next, phenol on bromination. Like reacting with a bromine in the presence of an carbon disulfide CS2 gives an parabromophenol and orthobromophenol. This reaction is known as a bromination. And phenol reacting with an aqueous bromine forms an 2,4,6 tribromo phenol. Next, phenol reacting with an H2SO4 at 293 Kelvin. Remember, these two reactions are sulfonation reactions, where phenol reacting with an H2SO4 at 293 Kelvin, where SO3H group will be attached to the ortho position of the phenol. Okay, now ortho position of the phenol will be attached by an SO3H group, whereas H2SO4 is treated at 373 Kelvin. At 373 Kelvin, the SO3H will be attached to the para position of the phenol. Next, we shall know about the ethers. So, in ethers, the general form of ethers will be RO or RO R prime. So, first we shall look into the preparations, where alcohol reacting with a concentrated H2SO4, alcohol reacting with a concentrated H2SO4 at 413 Kelvin gives an ethers, where alkyl halide reacting with an Ag2O gives an ether. Ag2O will be at dry condition. Ag2O at dry condition gives an ethers. Again, alkyl halide reacting with an RONA, Williamson synthesis reaction, gives an ether, where the alkyl halide should be primary, as secondary and tertiary alkydes undergo eliminations to give alkene. So this is important point to remember in the Williamson synthesis, where the alkyl halide should be primary only, as because of secondary and tertiary they undergo the elimination reaction to give an alkenes. So important point, remember. And even and another important point to remember is, to prepare an alkyl aryl ether, sodium phenoxide and alkyl halide should be used. To prepare alkyl aryl ether, sodium phenoxide and alkyl halide should be used. Okay, so no reactions we can take place if aryl halide is reacted with sodium alkoxide due to the lesser reactivity of aryl halides. So due to its lesser reactivity of aryl halides, so we cannot prepare an alkyl aryl ether by using an aryl halide and an sodium alkoxide. So this is another important point to remember in the ethers. So next we shall look into the properties or reactions of an ethers. When an ether is reacted with an HCl, when ether is reacted with an HCl and it forms an oxonium salt, like dialkyl oxonium chloride, forms an oxonium salt of dialkyl oxonium chloride. Next, ether reacted with a concentrated H2SO4 gives an dialkyl oxonium hydrogen sulfate. So please remember these important reactions. When an ether reacted with a concentrated H2SO4 gives an dialkyl oxonium hydrogen sulfate. These two reactions are used in the formation of an oxonium salt. So next, ethers on oxidation gives an peroxide formation. Ether, next reaction will be ether reacting with an HX, halogen acid, gives an alkyl halide and an alcohol group. Ether reacting with a dilute H2SO4 along with the water, it also gives a mixture of alcohols. Next, ethers reacting with an PCl5, phosphorus pentachloride, gives an alkyl chloride and an POCl3. Next, ethers reacting with an CH3COCl, an acetyl group. It's an acetylation reaction. So ether reacting with an CH3COCl in the presence of anhydrous AlCl3 gives an esters. So next, ester reacting with an Al2O3. Ester reacting with Al2O3 at 300 degrees Celsius, it gives an alkene. As it undergoes a dehydration. Next, ethers reacting with an chlorine. These two also important reaction to remember. ethers reacting with an chlorine at dark. At dark, what happens means like the alpha hydrogens present in the ether will get replaced by an chlorine. So hence the product formed will be an alpha dichloro diethyl ether. In the dark, when an ether is reacted with an chlorine, it gives an alpha dichloro diethyl ether, in which alpha hydrogens will get replaced by an chlorine. So next, same reaction in the presence of light. When an ether reacting with an chloride in the light gives an perchlorodiethyl ether. Perchlorodiethyl ether, which means all the hydrogen atoms will get replaced by a chlorine, and even here chlorine will be used in the excess. So what happens when an ether reacting with a chlorine in the light? All the hydrogen atoms will get replaced by a chlorine. So next we should look into the aromatic ether, that is anisole. So anisole is prepared by an phenol reacting with an CH2N2 gives an anisole. So next we shall look into the properties of anisole, where anisole reacting with an hydrogen iodide gives an phenol, and along with that methyl iodide will be formed. Next, anisole reacting with an HNO3 in the presence of H2SO4. It is a nitration reaction, gives an orthonitro and paranitro anisole. Orthonitro and paranitro anisole. So next, anisole reacting with an bromine along with this carbon disulfide. It's a bromination reaction. It is also gives an orthobromo anisole and parabromo anisole. So this is about an ethers. So apart from this, some of important points to be remembered are like in the alcohol part, like C2H5OH, it is also called as a grain alcohol, which is also used in the beverages, and 100% ether alcohol is called as an absolute alcohol. So 100% of ethyl alcohol, C2H5OH, it is called as an absolute alcohol. Next we have methanol like CH3OH. It is a poisonous one. It is a poisonous, and it is also called as an wood spirit. So these two are important points to be remembered from an alcohol. And the test for alcohol also you should remember. Sometimes they might ask, like alcohol is reacting with an ferric ammonium nitrate. What will be the observation? Pink or red color will be formed. So next, like alkyl groups in the ethers. In the ether part, another important points to remember will be like diaryl ethers are not cleaved by hydrogen iodide. So this is an important point to remember. I forgot to include in the previous discussion part, where diaryl ethers are not cleaved by hydrogen iodide due to steric inheritance. Steric inheritance means when a molecule has a multiple bond other than the hydrogen atoms, it can slow down or prevent the reaction with the other molecules. Okay, so this is an steric inheritance, where it slow down or prevent the reaction to take part by the other molecules. So this is a steric inheritance, which is very important topic or point to be remembered in an organic chemistry part. So next, apart from this, that's it. No more important points are there for your KCET examinations. And thank you all.